should go from index number 1 to index number 4. N is 6. So it will go to index number 1 to index number 4. AI should be greater than its previous and next. Both. Current element should be greater than its previous as well as next. And this is not satisfying. This is satisfying. Here 3 is not satisfying, 9 is satisfying, 10 is satisfying, 3 is not satisfying, 1 is not satisfying, 5 is not satisfying, 5 is not satisfying. So 9 and 10 are satisfying. So answer is 2. Just greater than both their neighbors. Why are this failing? Point I equal to 1, I less than equal to 1 minus 2 I plus plus. I should be from 1. Uh, uh, and should not reach the last element. That is less than n minus 1 or less than equal to n minus 2. It's the same if the current element is greater than the previous is accessible, and the current element is greater than it, then the next element. Next element is accessible because I goes till n minus 2. So a of n minus 1 would be accessible. Count plus plus. Here is 1. Here, sorry. This was getting inputted. Time is the given integers m and d and a string s of length m, the system of g and a dot. Integers m and d, which are from 0 to 100. M is strictly given and d, and both are integers. From 0 to 100. There are m cells arranged in a row, from left to right, numbered 1 through n from the left. Some of the cells have a guardian standing on their cells. Specifically, guardian stands on cell I if Si is equal to C, and no one stands on cell I if Si is equal to dot. Cell whose distance from the cell is to the guardian is equal to D is watched by a dead guardian. That is, a cell X is watched by a guardian if there exists a cell I, such that Si is having a guard, and mod of X minus I is less than or equal to D. Among the M cells, find the number of cells that are not watched. 7 is what? 7 is the number of cells. Okay. And 1 is the distance to which it can watch on both sides. So this guard can watch this two positions. This guard can watch this position and this position. This guard can watch this position. These two positions are safe. What is the answer? They are not watched. If this is already watched, no, this is on this position. Right. So we have to find that dot which has uh, no G in the range D on both sides of it. Okay. So how can we prevent this? We have to find first we need to create this call just solve function in and the length and the distance to can watch. See in in S, C in S. Okay. Let's take this example. And this is only on part one. Yes. The one, the five. There is no guard, so avoid any message. परत गया ये दो देख सकता है, ये दोनों सुन रहा है, ये दोनों गए, फिर ये दो देख सकता है, और यहाँ देख सकता है गए, ये दो देखेगा, और ये दो देखेगा, गए, ये दो रह गए, तो सेफ, और ये रह गया सेफ, तीन, और तीन तीन छह ब्रांच, राइट? If we iterate on this thing and go on dots and check if there is and check if either on left side or right side there is no guard after within this position, then it can be counted. For this thing, there is no left, so we don't go. We go right and check up to conditions of two. So we can optimize it by storing the occurrence of G in a map or a set. No, map is better in this case. It's map of character, comma, the index in which the guard is there as can be. Secret to the string for and for being to user and index level indicator. So we have to store it listed in the map. I equal to 0, I less than length, I equal plus. What we do? So if s of I is a guard, we insert that in a map. Map or set. If we insert in a set, we can use the lower bound function for that. Suppose this is index number 0, 0, 1, 2, 3, 4. The set will be having 4. We are having 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 guard positions. We started editing again upon index 0. We find the lower bound. The bound is 4. The next nearest guard is 4. It says because 4 is greater than 2. After this, we come to 1. Okay, come to 1. 1 finds at 4. Again, 4 is greater than 1 plus 2. So that's why it is also said. For this, we find 4 which is not greater than this 2 plus 2. Just this is got. For this, again, this will be got. This is G for this. If we find a lower bound, we will get this index, not this index. No bound will give greater than or equal to that value. It will give 8, 4, 5, 6, 7, 8. For 5, 6, 7, it will give 8. It will give 5, it's not. Constraints are low. Yes, length of the string is also pretty low. You can do it. You can, uh, we don't even use a map. We just iterate again and again, right? In both the sides. Then we can find proximities. count answer. We check. We will make a pointer for every dot and count for every I dot where there is a dot. Find if the distance, right? The distance. We won't go to the left if we are now if we are less than an index of d, and we want to right if we are there or there. So check if I index of d is 2. If I is less than d, we won't go right. But if I is greater than or equal to 3, we will go left. We can go left. Okay, we can go left. We will check. We can make uh, Michael's left pointer length left is equal to current position here. Just anything from here to there. Left we can go for these positions. This minus d within this. You can just start left from the sky and go to the d. D is in d is less than M100. While left while left is while let's go we start from this side. We go to the left. While left is greater than 0, yes. We are currently left is equal to I currently. We can go S of left is equal to G. No, we go to left minus minus. Okay. You can start from I minus 1 option. Let it be. S of left is equal to G. And that's pretty fine. Right? It will be defined because D should be a check. D is D can be 0, right? Okay. Left minus minus. Go here. Check if it is a guard. No. Again, left is positive. Can go again. We come to 0. Guard, no. Guard, no. Left minus minus. Left will go to minus 1. And then it will breaks. It breaks. Okay. If it breaks without, if left is negative and it breaks. If left is negative or like left comes to 1, 2, 3. Left is I minus D. Left is less than I minus D. Then you have to trigger answer because this is the safe point. Cannot be seen to the left. Okay, right. We also this is safe. Currently, it is safe. Left safe. We can write a bull. Bulls the left is equal to false. Left left state or the right. If we want to, like, we like right is equal to I, right underscore save is equal to 2 while right, oh no, I think 1 minute. I is greater than equal to 3, then we can go to the left, right. But we can't go to the right if these are from the end, they are from D questions. I get them 3, and if you know, right, already we have done this. Then split it into 3 cases. I get into D, and I, this is N. This is N minus 1, N minus 2, or 3, N minus 3. Go to N minus D minus 1. Go to N minus D minus 1. Suppose D was 3. We could go till uh, here, right? We can go to the right. 1, 2, 3. We can't be on these 3 and go to the right. Uh, but the G is there, right? Like this is also not safe. Get caught. For every dot, we should store the nearest guard it has. Dot should store in the guard. Store negative elements. One over the guard, five over guard, six over guard. One can D is one. Not this is given to three on there, right? You can solve this by using uh, instead of going on dots, we can go on guards. That would be easier. Simple. First, we can store all the guard index per set. Guard complete set or something for I equal to 0 by this thing and this. Uh, I is a guard. If it's a guard, then guard guard cover. If you are a guard, then no matter what value I you will store guard covered with this below or insert this I out to be right or to be only and left it to the right. Count is 0. We want 0 distance to the left and to the right. While count less than D, we will do this stuff right there. Just insert I. That's something like that. Okay. Then we can go count plus plus. Product index 1 will insert 1. Then we will insert like this count, go to the right. We are think of right or left. Okay. Now you reset the count to 0, again go to the left. While count is less than D, not to be R to index dot insert I minus count for the left position, count left. Okay. Then after the guard, get or in the I equal to represent and like if you are a dot, you are a dot. Are you there with the guard set? Dot find at the count and you can find I this index is equal to is set dot and you are not there in the guard for the reason then you are good asked. You are part of the answer, otherwise you are not. See out only if you are a dot. Then you will consider for the answer. Count for how you are a guard. So you are this one. You are at one. Then you go till I plus D. I plus D only. I plus d is 1 plus 2 is 3. 1 plus 1 is 2. 1 minus 1 is 0. 5 plus 1 is 5 minus 1 is 4. You also insert I, right? So for your count start from 0. I plus 0, I inserted. I plus 1 and I plus 2. For these 2. That's the question, right? Yes. Yes. These 2, then you can go look up to 2 positions to the right and 2 positions to the left. Count it. It reaches D, then you stop. Uh, then 0 and D is supposed to. Then you insert I plus 0. Now you go to 1. Insert I plus 1. Now you go to 2. I and I plus 1 are inserted to these 2. Now what is something else? I, I plus 1 go these 2. I plus 1 is inserted and I plus 2 is also inserted, right? While count should not be complete. Plus 1, right? For these 2. For these 2. So we will insert I plus 1, showing that insert I will be 1. I will be 1. You have inserted 1. Then you get is 2. So you insert I plus 1. I plus 1, count comes 2. Again, then not equal. I plus 2 is inserted. Then it comes I inserted, I plus 1 inserted, I plus 2 inserted. That's right. So we uh, copy from this is I have been inserted, right? Inserted. Today I'm taking too much time. What is the simple questions? Between P and Q. You're given an integer n and an integer sequence. And integer sequence is P1, P1, P2, Pn, and Q1, P2, Q1. Okay. So there the integer n. And there are two integer sequences, P and Q. Each of which is combination of one to n. Okay. Okay, okay, okay. There are two permutations, and these permutations are P and Q. And the number of integer sequences that is a combination of 1 to n and are lexicographically smaller, like lexicographically greater than P and lexicographically smaller than Q or less than Q. That's what we means. Okay. If one or two kilohertz, then smaller, but length is n, right? So let's set the numbers 132 and 312. It is P and Q. N is 1 but to 10. Okay. So what you want to find? Number of number of sequences that are combination of 1 to n that are between P and Q. 132 is the maximum sequence is starts with 1. You have to start with 2. 2, 1, 3, and 2, 3, 1. When you start with 3, that's the first few. So you want to do the roughly smallest sequence, which starts with 3. That's where these sequences are between the P and Q. Also, list number is 2. And that will be strictly greater than P and strictly lesser than Q. And it's 10, right? At most 10. 10. If we generate all possible permutations offered from 1 to 10, how many permutations exist total? Uh, when the digits are from 1 to 10, 10 length permutations. 10 factorial, right? 10 factorial, how much? 10 factorial is not a very big number. Factorial of 10. Factorial of 10 is a big number. It is 36 lakhs. 36 lakhs, which means, like, if you make it 40 lakhs, that means 4 into 10 power 6. And the time limit is how much? The time limit is 2 seconds. The limit is 1 to 0 to 4. MIB. What is MIB? Ah, so, yeah, if we have a next underscore permutation keyword in this SQL function. That's this line. Ten power 8 operations per second is allowed. Yes. And there are no test cases there. So time limit of 2 seconds means in 1 second we can do 1 into 10 power 8 operations approximately. In 2 seconds we would be able to do 2 into 10 power 8 operations. 2 into 10 power 8 operations, and we got 10 to 4 into 10 power 6. So we can use brute force here. We can use brute force here. There is a scale function next under brute computation in C++ scale documentation. It's first or last. Last is computation here in factorial possible arrangements. First and last. Non-element quantity and last. Okay. Example is suppose there is a list minus 1, 2, 3. Sort minus 4 minus plus 3. Minus plus 0, minus plus 1, minus plus 2. They are sorted in diagrams. But since this function, this function is mostly used in dual. This function accepts the last is not pointed by the last. So we have to increase it by 1. Okay. Then we can generate all the 3 factorial propositions. Once we have generated, and there are 4 into 10 power 6 combinations, right? Memory can be exceeded, right? What is good for want? Check this combination. This current combination is within this tool. This current combination should be greater than the then also it will be difficult to find the range. So that the combination so how to plan 5 foot 5 inches. Again, P is greater than Q, then you cannot have any answer. It will be zero. This is right. P65415. So there will be 37 multiple ones. This example, if you reverse P and Q for getting a non-zero answer, so P is 51234 and Q is 54213. Starting with 5, both are starting with 5. Let's suppose starting against the same. Then we can think of the next element 1, and that's 4. First, we have to complete 1, 2, and 3. So 5 is fixed. 1 comes the second element, 5 is fixed. Considered and 5 is fixed. Considered. How many conditions of this kind? 3 factorial, 3 factorial, and 3 factorial. Yes. Then comes 5, 4. 1, 2, 3 will come, right? And then 5 to 2 and 3 will come. So plus 1 will be there, right? It's 6, 6, and 6. 19. There are 90 combinations in between. No, in between now. We have to subtract one from here because P is equal to that. It will be 18 combinations. Five four one three, 54213. Let me close the bracket. 500 and then there would be a together. Like a color. फिर 1 to 0 1 से 2 को आएगा 2 आएंगे यहाँ पे 19 वाला आंसर microfunctions. But we have to approach 5 is matching very good. 1 and 4 are not matching. There are like first you have to cover 1, 2, and then 3 to reach this. And when 1 will be there will be a these three will be permuted. We have 3 factorial permutations. For total, when it's a factor, so it is complexity. 1 is equal to seconds. Then when 2 is there, 5 is already there. Again, we have 3 factorial permutations. 3 is there. Again, we have 3 factorial permutations. That's the reach till 3. Okay. Now 3 then we'll start with 5, 4. Right. Now 4 will come here. Okay, 4 will come here. At the second position. Now in third position, we will start with 1. We have to reach 2. Hmm. Then it's next competition then. It is. Can store, I think. There is function. Yes, this is a function like psychographical components. By default, this function checks if the first frame is less than the second, so we can begin to reverse or almost check if it's greater than. Yes, like for example, vector in population 1 plus 3 to vector in population 1, population 2, 1 to 3. Whole is greater. Yes. STT, lexicographical compare. Population 2 dot begin, population 3 dot end, population 1 dot begin, population 1 dot end. These are order and right. Yes, fundamental relational operators are already ordered on a sequential comparison for type. Okay, that's better. That's even better, right? Important is that to implement this. This may not work, but as time efficient. It's fine. We have 100 times uh, within the bound. So it should work. This is the function, right? This is the ordered and mode. So this is the upper bound function. So complexity is n. Uh, so implementation, yes, it's the implementation. It's not n, but it's not n. Implementation. 13 of it, for sure. Do by this n vector and rotation 1 p of side n, comma q of side n, for n pi equal to 0 to pi less than n pi plus plus p in p of I c m. Then writes what? You solved it first, right? Sort p first. Sort p. Then only you can use factor. and small speed. Create a vector in them before the thought, them could begin and then dot. Let's do this. And then we do the while loop. While next permutation, what to do. If the current temp is P, like with current S, the current temp is P, then we can start the count, right? And count will give temp has reached getting P and temp is less than we can count this. If it is that very simple, I don't think so. Get a bit count this plus. Very yes. But we will get the argument or not. We are storing the permutation, right? Permutation size is n, it is less than equal to n, right? And it is greater than or equal to 1. You also greater than equal to that's very less. 10 factorial is 4 into 10 power 6. We are not storing anything. We are just doing a 10 comparison. This is order 1 in itself. This one is ordered 1 in itself. Right? This comparison, no, it's not order 1. This is not order 1. If we have implementation of solution, right? Bidirectional iterator. So, that's an order n. This comparison is also order n, right? For any experiment. Simple solution if n is large. It works. Yes, it works. But need to think of a solution if n is not very small. I should change that. We also like even any so we only decide establish the words of contest. Palindrome. The palindrome is the problem statement. String consisting of lowercase English methods is called a boost string if it sets up a polygon. String is called a boost string if it can be turned into a palindrome by rewriting at most one character. Can turn into a palindrome by rewriting at most one character. And we can change no character or we can change one character. You get the point. Example A, the early palindrome, so I can also get things with the previous thing. IWAI. If we write A instead of the W, then it becomes A, B, C, D, C, Z, A. This is Z actually B. And you also good string. We will string as its from longest number of systems in the distance. Number of non-substrates of exactly good strings. Two substrates taken from different positions of layer are counted separately, even if they are equal as strings. Okay. Length is 1 bit about force. Okay. The string is given ABA. But to count the number of substrates which are non-empty and which are good, this ABA is good. This ABA is also good. This ABA 1, this ABA 2, BA, BA, AB, even BA, BAB, and BA can be changed for that, right? Because you are told 13. How much time are we left? Let's check E also. check good string we need order and time for a string. Find substrings which are palindromes. Strings which are palindromes. Substrings which are palindromes. Which, if we get a substring, if we fetch a substring from S, then we can check if it is good or not in order and time. But how do you get substrings? Because N is the 10 power 4. Let us see. Uh, number of points let us see. साढ़े सिंह में तो एम्पल वाला दूंगी एम्पल वाला वो टीम ए टू जाए बड़े सिंह के चेक करेंगे कि वो है कि नहीं तो ऑर्डर एनक्यू सोल्यूशन तो है ऑर्डर एनक्यू सोल्यूशन है हमको ऑर्डर एन स्क्वायर चलना एन स्क्वायर चल जाएगा ऑर्डर एन स्क्वायर वाला ऑर्डर एनक्यू है हमारे पास ऑर्डर एन स्क्वायर चाहिए है जैसे कर सकते हैं एनक्यू में क्या है कि हम लोग हर एक सब्सिडी निकाल रहे हैं और चेक करने की बुढ़ा के लिए हर एक सब्सिडी के लिए करो आपको उसको ऑटोमेट करना है कि हम हर एक सब्सिडी के लिए चेक ना करें कि वो गुड है कि नहीं गुड का कंडीशन क्या है कि वो पैलिंड्रोम होना चाहिए या फिर वो एक ऑपरेशन करके पैलिंड्रोम कन्वर्ट हो जाएगा ठीक है? तो फिर इसका पैलिंड्रोम तो कुछ करेंगे नहीं हम लोग। कुछ कॉल कर जाएंगे कुछ लेकिन पैलिंड्रोम नहीं है पैलिंड्रोम ठीक है या फिर एक बार ऑपरेशन करके वो पैलिंड्रोम बराबर हो जाए और एन स्क्वायर चाहिए I want an order and space solution for this uh, solution. Active value converted to n square. What is power? Two length string is always a good string, right? One length string is always a good string, two length string is always a good string. Three length string, three length string would be what? A three length string would also be every time a good string. Why? Because we can apply one operation and then we can get uh, kind of ACB. We can say B to A, ACA, ACA. Up to three lengths of strings, everyone is everyone is a good string. But beyond length strings, we are stuck. Whether it can be 1 to 2, or random or not. One operation. What if you don't need a checker for goods? If we generate all possible substrings, then we will just build a order one goods checker based on some pattern. What pattern? If the length of the substring chosen is less than equal to 3, then return true. It is good without even going. Otherwise, you have to check the characters and still it is forgotten and right. But we are allowed at most one operation. Okay. This thing we got dense fruits. This is the string A, B, C, C. And if we check, we need to check just A and C, first and last. They are not matching. We need to make this A. Or do this with this. They are again not matching the breaks. Which turn false. If we had A, B, B, C, then we could have done A and then they're matching. But we have to make sure into it was the entire, even if the regarding one number of operations given is one, can't skip in between. As soon as two pages on front that I have no match, I can return false. We need to solve this.